Okay, so guys, how about this one?
That looks like y equals x.
Wrong.
So I will give you this.
Oh,
So that's the point 0, 1.
y equals x plus
I
1.
don't know. You're right.
So y equals x plus 1 is a very reasonable guess, right? Doesn't it look like the slope is 1? And based on the point that I've shown you, the y-intercept is definitely 1, is it not?
Yeah.
And it looks like the slope is also 1.
Wait.
Does anyone want to venture a guess what this really is? Because it's not x plus 1. It's e to the x. Any other guesses?
Yeah, it's easy.
It's e to the x.
Ln. No. Contrarian.
Okay.
ln of 1.
All right. Why don't I just do this?
Just some function.
I'll show you
I've never heard of, some obscure, like,
the equation.
3 pages back.
These bars thing.
You were right. It's e to the x. Okay. So we zoom
Absolutely.
way back out. Now, check out Peyton's idea. She says x plus 1. I'll put it as 1 plus x. That's actually around 0 is quite good, is it not?
Oh, nice.
Okay. So 1 plus x.
Over.
So if I did over, so what do you think? Over what?
No.
No,
Don't
just
divide
over
it.
1.
Two.
Oh, sorry. Don't Meg. Sorry.
No, I'm trying to just keeping it.
Is that better or worse?
Well, honestly, it's kind of bad.
That's worse because it
That's-
crosses.
That's worse. Check this out.
Yeah, Meg.
Because it's a tangent line when it's 1. Because
That's the tangent line. Like the tangent line needs to be the tangent line. And by the way, what we did on the sine graph, didn't we find essentially what amounts to a tangent curve? We made the curve fit to the graph.
Yeah.
That's what we want to do here. I'm kind of curious. Hang on. Let me do the error thing. This might be helpful. So
x squared.
really close to 0, it looks like what?
X squared.
Doesn't it look like a parabola kind of?
It's
what
a
do you-
hyperbola.
So we're just talking about close to 0. So if I went plus x squared,
Nope.
interesting.
No.
That is the right term, but what could we do to this to make it better?
You divide it by.
What would you think we should divide it? You said 2.
Oh,
We'll start with
yeah.
2. We'll start with 2.
No. Wait.
Is that better?
Yeah, that is better.
I don't think it's worse.
No,
no,
I just
definitely
made the
better.
right side.
It's actually better.
So what's x or what's plus x cubed?
So the truth is, the division by 2 there is correct.
X cubed over 3.
Okay.
X cubed over
So plus x cubed
Because it's a factorial. You might be right.
over 3.
Oh, wait.
And
Oh, shoot. It's probably
I'm
not.
a
And-
king!
was there another proposal?
I kind of liked it on the right side.
Oh, yeah. That's
Plus x.
Well, what's to the 6?
Okay, let's check. Instead
I
of
just want to keep.
so,
looking at it.
try to memorize this real quick. I'm going to change it quick. You ready? Is that better?
Yes.
Yes.
It is better.
Yeah.
It is better.
So it's still the factorial.
It's still the
situation.
factorial. All right. Well, let's see if we can keep going with that. What do you think the next term should be?
24. What?
Over 24.
4.
X to the 4th over.
Yeah, 24.
Whoa, that got good fast, didn't it?
Guys, we're so good at this.
Wow.
Wait, but you're adding all of them. That's weird.
I am. Did you notice that x squared looked like a positive? You guys have just been saying plus, I thought, or maybe you've just been saying the term.
I have nothing.
It's right.
And the truth is here we should just be adding
Because
every
this graph
single
never goes below 0, and it never, like, dips.
True.
Wait, so is the power series of this always going to diverge at the, like, near the asymptote? Because it's never going to be able to, because it's always going to go back and forth from up and down. Because, like,
Well, let's see if that pattern holds true. So x to the 6th, or sorry, x to the 5th over
120.
120. Okay, now watch.
Plus minus.
See, I was making that.
So can you see how that tail on the left side goes down, up, down, up? The end behavior is changing each time.
Yeah.
And so you said,
Times it'll.
diverging from
you're saying like will get diverging over there?
the,
No.
they get accurately
So, well, no, it's actually a pretty good word. The truth is that as we add more and more terms, that tail will continue to go down, up, down, up, down, up, but it'll keep getting pushed way out to the left, further and further and further.
Just be like
Huh.
So what do you think the next one should be? Plus,
to the 6th over 6 factorial.
which
was gonna
is
say-
720.
Yes.
I don't know.
It's getting a little bit better. so on and so
Six
forth.
factorial.
So guys, this is it. So with e to the x, the pattern is essentially x to the n over n factorial, and everything's being added instead of the plus minus we saw with sign.
Do we have to memorize all of this?
It won't be that hard. We're going to do it so many times. There's only 4 of them. There's only 4 of them you have to have really solid. One thing I want you guys to think back about, I didn't mention this before. You remember how sine, like the degrees and the factorials were 1, 3, 5, 7, 9, 11, 13, 15? Obviously, those are all odd numbers, right?
So,
You remember that sine is considered to be an odd function with symmetry about the origin? So when you make a polynomial for it, you actually get all odd exponents and all odd factorials as well. But the odd exponents, right? Remember that was one of the rules for odd functions, is that all of the exponents have to be odd? You have that with some.
Oh, great. We went over this in class last semester.
Well, I've definitely been foreshadowing this a lot.
Oh, yeah.
Yeah, we wrote it out on the board of like.
This very series, yes.
It was something, yeah.
It was this very series. So let's do this. We only have about 5 minutes left, and I thought I'll just let the cat out of the bag on one more. Nick, your question?
Would the sine of
cat
x?
back in the
Would the
bag.
cosine of x?
That's where I wanted to go.
Oh, is it just really close to sine of x?
So cosine of x, I'll build this out for you. So I'll write g equals, here's how it starts off. Oop, I don't want that.
If you want to
Like a normal lateral shift.
Go away.
From like the.
I'll put g of x, maybe that'll make it happier, equals 1. And I'm going to change the color to
or whatever.
red.
And then when you do it, would it be like 1 minus?
So, by the way, isn't cosine even?
Oh.
Y-axis symmetry?
It's gonna be 1 plus x
Close.
minus x.
Minus. Watch this.
Plus x
It's a pretty good tangent parabola. There we go. Plus x to the 4th over 4 factorial is 24. And then the next one would be minus x to the 6th over 6 factorial, which is 720. You can see how we're getting better and better. And of course, the end behavior is going to go from down to up, down to up, down to up, like that. We'll just keep widening out that interval of convergence. So again, I want to remind you, one of the big points of this is polynomials always simpler than non-polynomials, just how it is. And so we're going to be working to build. These. One of the things we're going to be doing early on is we're going to be talking about ways that we can be describing error, because we know there's going to be error, right? You just zoom in enough, you're going to see we're actually off, even though right here it looks like really good. We're always going to be off by a little bit. In fact, we're going to find that the only place of true convergence is at the centering point, right? So it's going to be at x equals 0. For these, all the ones we've done today, the only place of complete perfect convergence is right there at the centering point. And once you move off that, there's going to be little smidgens of error. And so we're going to be talking about, like, what are the patterns that lead us to be able to, like, discover what the error would be bounded by. Yeah. They just look, I mean, depending on how far zoomed in or out you are, the place where we're going to go when we officially get to power series, what we're going to say is essentially the limit as the number of terms heads towards infinity is not a tangent curve anymore. It's exactly cosine, or it's exactly e to the x, or whatever it might be. Okay, that's if the number of terms is heading towards infinity. We know it will perfectly mirror the original graph. Yeah.
If it's like changeable, it's like cosine 5x.
So that would, let's see here, that's going to change your coefficients. Your coefficients would then actually, like, the numerators would be different. Your numerators would go, well, the first one would still be 1, but then your numerators would go 5, 25, 125, chain rule. Repeated derivatives, 625,
So it'd just be that
3125. There would just be like 5 to the 1, 5 to the 2, 5 to the 3 being multiplied times the numerator.
Okay.
So, and that kind of like, flattens it out a little bit, right? And we're going to learn how to build those.
Okay.
We'll learn, like, other than us, like, being really good guessers, which you guys are actually quite good guessers, Other than that strategy, we'll learn an actual strategy that is like dependable and always works.
Okay.
So,
Is this in our notes about you?
So-
I'm gonna need to write this down.
no, we're going to cut. This is just total preview. We're going to come all the way back around to this. You don't really need to take anything away from today other than just the fun and hopefully interesting stuff we talked about. And I will reference this later and say, hey, do you remember when? And you'll say, oh yeah, and then I'm going to say,
Remember when it was
fun. So there's no quiz on this on Tuesday or Wednesday or anything. Hey, did y'all notice we have a Luke quiz coming up next week?
Yeah.
Thursday, I want to say.
Thursday, is it?
Thursday, I think. So other than that, just bring your notes packet for series on Wednesday. We'll do a little more work in series on Wednesday, and then we'll be off and running, okay?
When you say Luke quiz, you mean
Great
semester one, right?
job. Say again?
Luke quiz means semester one?
Let's see here. Yes, I think it's everything but, I put it in the calendar. I think it's like everything but polar.
Okay.
Yeah.
I think it's, yeah, everything but
Will
polar.
there be any like study materials on there? So
Should already be on Schoology right now. Yep.
perfect.
Thanks, Mr. Anderson.
Yep. Thank you guys. Enjoy your weekend. Good job, you guys. Way to go, Sam. You were the original pattern finder. Nice work.